Thanks, Alistair. So, Andy, Steve, thanks very much for the invitation to speak. Whatever you call me, I'm just glad to get called, so that's good. This talk today that we pulled together, it's very light on detail. I want it to be just a broad overview to give you a sense of what's going on in Lake Ontario right now with respect to acoustic telemetry projects. I've broken the talk into three sections. We're going to touch a little bit on what is acoustic telemetry, if there is, in fact, anybody that's not familiar with it yet. The bulk of the talk, we're going to talk about the Lake Ontario projects, try and give you an introduction to who's doing what, and maybe touch on a little bit of results from a few of them. And then I've got a few slides at the end to talk about some future possibilities. Before I begin, though, I want to acknowledge that although I'm the one standing up here threading these slides together, this is everybody else's work. There's a lot of people involved here, and so I'd like to start by thanking all of them for continuing to respond to my emails and send me photos and bullets and slides and answer my questions. I really appreciate the help from everybody. I'd also like to acknowledge Nancy Nate over at GLaDOS. Again, she continued to return my emails and generate summaries for me on a very short notice. So what is acoustic telemetry? Really all I wanted to say about acoustic telemetry is it's very similar to what I think of as more traditional forms of telemetry. It utilizes a small transmitter or tag that transmits a unique serial number in the form of an acoustic ping, but a little bit different from other more traditional forms of telemetry. We generally don't go around with a receiver and an antenna and go looking for our fish. With acoustic telemetry, there's a lot more of the use of receivers being moored out in the lake, scattered them around, and they sit and passively listen for fish. And so what you end up with these sorts of setups is a lot more data. You've got data collected not just on a 9-to-5 basis, but you can have receivers collecting data 24 hours a day, 365 days a year. We can't talk about acoustic telemetry without mentioning GLaDOS. The Great Lakes Acoustic Telemetry Observation System, GLFC is very familiar with it. It's a network of researchers that have agreed to share data, and I think it's fair to say it's a very successful data sharing group. Everybody agrees, here's where my receivers are, here's some of your fish that I've picked up on them, oh, you've picked up some of my fish on your receivers. We share the data, and I think it's led to some really interesting things that some of the other talks later this afternoon are going to get into. I just wanted to point out also how acoustic telemetry is increasingly, people are going to it to answer questions out on the lake. In 2016, GLaDOS had 160 members. In the last year, they've added another 81 people, 82 actually. Somebody joined the other day. Number of receivers that have been put in Lake Ontario. This bottom number here is the number each year. It's on a slow but steady increase every year. Number of fish tagged. Aside from a little dip in 2014, the number of tags that are going out into Lake Ontario are also increasing slowly every year. Number of species tagged, I think we're somewhere up around 26 species right now, with largemouth and common carp being the two most tagged species, but there's a bit of everything on here. Near shore warm water, offshore deep water, and everything in between. Projects. Let's talk about the projects. That's what I'm here for, is to try and introduce some of the projects. We're sort of going to start at the west end of the lake and move east. That's kind of how it goes in my brain here. We'll start down in Hamilton Harbor. This is a project that's being led by Steve Cook's lab, but there's, like with all these projects, there's all kinds of people that are involved in pulling these projects off. Jill Brooks has got, she's got a number of receivers and tags in the harbor. She's trying to learn more about walleye spawning locations, walleye movements and habitat use. And there's some more pointed questions around use of degraded habitats and remediated habitats. There's about 28 receivers, 50 fish tagged out there. If you stick around for John's talk a little bit later, he's gonna talk about some of the results from that project. The Toronto Harbor AOC project. This one, again, Steve Cook's lab, but lots of other people involved with it. I think it's fair to say this is probably one of the longest running acoustic telemetry projects on Lake Ontario. They're trying to learn more about habitat use by embayment species, but also how it's influenced by the proximity, I guess, to the open lake, and some of the temperature swings that you can see in that area. There's currently 50 receivers and 120 or roughly 120 active transmitters, but they've had more than 400 tags go out over the life of the project. The Western Lake Ontario Array, this is a fairly new one. This is an attempt by John Midwood at DFO to quantify the connection between Toronto and Hamilton and some of the other key habitat features along the western end of the lake. There's transmitters out at a number of upstream and downstream locations, but also transmitters out in deeper water now, out in the open lake. And again, in a few talks here, John's going to come up and tell you more about that. Critter River Atlantic salmon movement. This is one that's being led by Sarah LaRocque and Aaron Fisk at the University of Windsor. She is trying to learn more about smolt survival and environmental cues that make these fish move in the river. Also learning more about access to spawning habitat and potential barriers to movement. She's got both 69 and 180 kilohertz receivers out in the river. She was just out, I think, last week and the week before, putting her array back out. She's got a number of fish tagged. And she provided me a few results here just to throw out to get people thinking about it. If hopefully it piques your interest, you can contact Sarah or I can put you in touch with her. Some of the things that she's learning so far, just from an early look at the data, what she's calling wild smolts. They tend to move faster and further within the system, but also have a higher survival rate than the hatchery fish. Returning adults don't appear to reach what's considered ideal spawning habitat. They move so far, what people have deemed ideal spawning habitat is actually further up than where they're moving, and so that's been interesting to learn. Overwintering and high in-stream mortality. So a lot of fish that are in the, sorry, I should explain this. This figure here has got river kilometer, so distance from the open lake on the y-axis, and we've got time across the bottom, and each circle is a fish or a fish detection. And what this figure is showing is that there's a lot of fish being picked up in the fall, and then some fish being picked up in the springtime, but not a lot of fish over winter. But we also aren't seeing them exit the river, so we're not really sure what's happening to them, and I assume it's in-stream mortality. And then one other interesting fact was just that Sarah's detected sea lamprey from Lake Erie on this array up in the credit. Open lake, so modded movements. This is another one of Sarah's projects. She's moved receivers out into the open lake with the help of a lot of people in this room. And she's trying to learn more about adult salmonid movements, but with a focus on Atlantic salmon. And The goal is to compare spatial use with environmental variables and prey locations, see if we can assess niche overlap. There's 22 fish tagged, 4 species so far. Sarah may have been out tagging last week, and if not, I think she's got a few trips out to put more tags out in fish planned very, very soon. And just really early stuff is that she's already seen basin-wide movements of fish that she's tagging at the west end of the lake are showing up at the east end of the lake within a span of a few weeks. Here's a project that Dimitri's already spoken a little bit about earlier. Lower Niagara sturgeon and lake trout. So this is Dimitri's crew, and they're trying to learn more about sturgeon and lake trout habitat use and river residency and spawning and feeding locations down there. I think we've seen a lot of interesting stuff coming out of this project. There's a number of receivers, both out in the main lake and all the way up through to the gorge. We've got fish tagged. What have we got here? 70 sturgeon, 20 lake trout. I know that some of our fish from the Bay of Quinte have been picked up in this array up there. And then I've got down here Genesee River proposal. That's probably an old bullet now, but proposal to put more receivers further down the lakeshore. Bay of Quinte, Cisco, and Lake Whitefish. This is a project that Bruce Tufts at Queen's University started with some of his students, and involvement with Jim Hoyle and the Lake Ontario Management Unit as well. And the goal of this was to utilize the array that's existing in the Bay of Quinte and see if we can get a better handle on the seasonal movements and spawning patterns of lake whitefish in Cisco. Tag 30 Cisco last year and 29 lake whitefish. We did see definite movements of lake whitefish, and they moved to areas that we think are possibly spawning locations, and then saw lake whitefish move outside of the spawning times down to the lower Bay of Quinte, and even make the odd foray out in the main lake. The Cisco tagging was not as successful, and so we're going to change up some things and try and do another 30 fish this fall. Bass movements in eastern Lake Ontario. Again, this is Queen's University, Bruce Tufts, his team, trying to learn more about what the impact is of long distance displacement on bass. So the kind of thing that you see with catch and release bass tournaments. Again, 43 receivers in the Bay of Quinte, but also 20 out in the Eastern Basin, plus others with the bloater array and other things out there. 60, 70, what are we up to? We're up to 78 fish tagged over the last few years, lots of data. I think what they've learned so far is that despite some fish making pretty incredibly large movements, no bass seem to return to their original capture location. And Adam was telling me that fish that were displaced from the main lake into the Bay of Quinte, less than 20% of those actually left the Bay of Quinte after they were released, which again was pretty interesting. And at the moment, the feeling is that the Bay of Quinte and the Eastern Basin just may be playing difficult for bass to navigate. Bay of Quinte and Eastern Lake Ontario walleye. So this is one being led by Aaron Brown and Jim Hoyle, and again Bruce Tufts at Queen's, wanting to learn more about the spatial ecology and movements of walleye in the bay and the Eastern Basin. Again, building on that or utilizing that Bay of Quinte and Eastern Lake Ontario receiver array. A number of fish were tagged in 2017. All I will say is that mature walleye appear to leave the bay soon after spawning. But again, Aaron's going to tell you more about that in the next talk. American eel migration. This is one that Alistair has been heading up in our shop, but also lots of other people, Tom Pratt and others, trying to get a sense of where the eels in Lake Ontario, where do they go? Do they move towards the Sargasso? When do they go and do they move together? This is another big project that's been going on for a long time. Nearly 200 eels have been tagged over the last few years. And there's receiver arrays both here at the eastern end of Lake Ontario, but also down near Cornwall and again near Montreal. Lots and lots of results coming out of this project, and I won't go over all of them, but I guess things that I thought were of interest. Survival rate of the tagged eels has been quite high, which is excellent. A number of eels migrated out of the Bay of Quinte and headed down the St. Lawrence. What else can I tell you here? 98% of the eels moving past the Iroquois Dam did so in the dark. Kind of neat. Movements past the dam down near Montreal were all after the start of October. We've got 4 have been detected out in the St. Lawrence River estuary, and 1 has gone even further, and I believe has been picked up on some of the World Tracking Network receivers. And again, talk to Alistair, he's got lots of information on that. Bloater in Eastern Lake Ontario, so this is Tim Johnson's crew along with the University of Windsor. We're trying to learn more about the post-docking survival and behavior, what happens to these guys after we pull the plug and dump them out in the lake. As part of this study, we've also looked at tag burden effects with the help of White Lake Fish Culture Station. Fish Culture Research Center, White Lake Research Station, whatever we're going to call it. We've also done some deep water range testing out there as well, and so this has been a fairly large project for us over the last few years. We are utilizing the geography or topography or bathymetry, whatever you want to call it, out there. There's a deep water trench out off of Main Duck Island that we have placed our receivers around to try and make an area where we hopefully the bloater will stick around long enough for us to get a sense of what survival and behavior will be out there. I think we're around 227 bloater tags so far. By the end of the year we should be up around 350. Again, you've seen a bit of this earlier from Jim's talk, but we have a very good initial detection rate, which is great. The residency within the array is highly variable, anywhere from less than a day to 57 days, with the average being about 9 days. We think we're seeing some seasonal movements in the winter and then returning to the array in the spring. We think we have observable habitat associations. Whenever you do these bubble plots, they all come out looking similar with a lot of use in certain areas. Some of our bloater have been detected up in the Bay of Quinte, some up in the Niagara River. So some of these fish do get around. Survival estimates at the 200-day mark, anywhere from 5 to 12, depending on 5 to 12%, depending on the model parameters you choose to use. Future work, we want to learn more about what drives movement and distribution of these fish, so we're doing a fair bit of work out there again this year with classifying habitat and tagging some predator fish. We were also utilizing sensor tags for depth and temperature, and then this fall we're going to bring some predation tags online as well. So lots going on there. Again, Eastern Lake Ontario, lake trout and Chinook. This is again Tim Johnson's shop as well as University of Windsor. Sylvia Ivanova, she has got some lake trout and Chinook tagged now out in the Eastern Basin, and we're trying to get a better sense of spatial and seasonal habitat use and then overlap between the two species. Learn more about maybe what cues influence their behavior, and ultimately learn more about energetics and production potential of those species. We got 30 lake trout tagged in 2016 with the help of NIDEC and LOMU, and then another 20 in 2017. We've got 8 juvenile Chinook tagged this past summer, and we plan to tag some more this summer. And lots of detections on our lake trout. I think we picked up all of our lake trout in our array at some point, so that was great. We didn't have anybody disappearing on us. It appears that some of the fish disappeared over the wintertime, but then nearly all of them came back to the array in the spring, which was pretty interesting. And that's me holding a fish. It's not photoshopped. Stony Island Lake Trout. So this is Brian Lantry and Dimitri's crew. Again, Brian mentioned this earlier. Want to learn more about spawning shoal use by lake trout, and so for this project, some hatchery fish were tagged and released in 2017. Chameau Bay, you heard a little bit about this already as well. This is again Dimitri's crew, as well as New York DEC and USGS, and again wanting to learn more about lake herring spawning, timing of spawning, site fidelity, that sort of thing. They've got an array on and around Johnson Shoal and over near the Black River Channel. 10 fish were tagged in 2016 and 38 in 2017, and so we should learn lots from that. St. Lawrence's Sockets is moving down the river a little bit. This is Carleton University, again, Steve Cook's crew, also John Farrell's crew as well, and others. This one, they're learning more about spatial ecology and habitat use of very small, very young muskie and pike. At this point, there's 37 muskie, 40 juvenile pike tagged, using very small transmitters, and they're looking here at some very micro habitat stuff. And then last but not least, St. Lawrence River sturgeon and eels. This is John Castleman and Colleen Burlick at Queen's University, studying microhabitat associations of eels and lake sturgeon. They're using a combination of acoustic telemetry and also radio telemetry to get some pretty detailed habitat use data. And this one, I suspect there are some papers being written up right now. So that's it for the projects. I just have a couple slides to talk about future opportunities, and specifically want to talk about the RAYON grant. It's RAYON stands for the Real-Time Aquatic Ecosystem Observation Network. It's a nearly $16 million grant that has gone to a number of universities in Ontario to do work on the lower Great Lakes. Universities of Windsor, Western Trent, and Carleton specifically. The grant is to provide equipment for the study of Great Lakes for real-time and continuous collection of data. And so I always include this picture because that sums it up right there. Sort of for me, it's a Slocum glider. You can fit them with all kinds of sensors, and they can collect real-time data for you. That's the photo I stole off the internet, but there's all sorts of things that this money can be used for. It can go towards more telemetry gear, more receivers, eDNA collectors, boats, trucks, whatever. This money will likely be coming online this fall, and a lot of the gear probably should go in the water in the spring of 2019. And that's it.